Hello students, you are welcome to Prepclass Tutors. Joining you is Mr. Chima and I'll be your Prepclass tutor today on chemistry. So today we are going to be looking at past questions on chemistry, JAMB to be precise, for the year 2020, and we are going to be looking at questions 26 to 30. Because in our previous videos we've done question 1 to 25. If you've not seen our videos, I must really tell you that you are missing out. You are really missing out, because we have done videos on WAEC past questions 2020 from number 1 to 50. So if you're a WAEC student and you've not seen this video, you are really missing out. So now, do not forget to subscribe to our YouTube channel so that you can be getting more videos like this. More video, though maybe you may not have seen this one I want to present. By the time you see it, you will now have a reason why you should subscribe to our YouTube channel and why you should like our YouTube channel. Now, after viewing our videos, we would like you to drop a comment on our comment section box, because Prepclass will know how or what you feel or think about our videos. All right, so a very quick one today. Let us look at questions 26 to 30, JAMB, chemistry to be precise, for the year 2020. So let's roll. Question number 26. 4 elements A, B, I don't know, maybe the typo there. 4 elements, it should be elements, S, plural. 4 elements A, B, C, and D have atomic numbers 2, 6, 16, and 20 respectively. Which of these elements is a metal? Which of these elements is a metal? Element A has an atomic number of 2, element B has an atomic number of 6, element C has atomic number of 16, element D has atomic number of 20. They are now asking you which is a metal. What is atomic number? Atomic number is the number of protons in an atom. The number of protons in the nucleus of an atom. Remember that atomic number must be the same thing as what? Number of electrons. Atomic number, which is number of protons, must be the same thing as number of electrons in an atom, so that what? An atom will be electrically neutral. Do you understand? So because in an atom the number of electrons or the number of protons is equal to the number of electrons, we usually use the number of electrons to write the electronic configuration or describe the electronic configuration of an atom. That electronic configuration of an atom will now tell you if that atom is a metal, a non-metal, or maybe a semi-metal. Do you understand? Now watch. Electrons orbit in nucleus. Let me quickly get the pointer. Electrons orbit in nucleus, in shells. So looking at the elements above we have, now let us describe these 3 elements A, B, C, D with their atomic what? Numbers. No, so excuse me, number 2. The element that's in 2, that is element A, that has an atomic number of 2. You can see here that 2 here, the first shell is filled. Do you understand? So this element A, the atomic number, has atomic number of 2. That 2 occupy the first shell. So here the first shell is filled. So it is a noble gas. This element is most precisely helium, because helium has an atomic number of 2. That 2 occupies its first shell. The first shell has a maximum number of, contain maximum number of 2 electrons. Second one 8, 8. You understand? So 2 here, the first shell is filled, so it is a noble gas. 6, that's B, that has an atomic number of 6. 6, the first shell, 2 electrons occupy the first shell, 4 electrons occupy the next shell. Plus 2 plus 4 will give you 6. So first shell 2, second shell 4. So you can see I said first shell 2 electrons, second shell 4 electrons. This is an element in group 4 of the periodic table. Is most likely not a metal. The number of elements, or the number of electrons rather, in the outermost shell of an atom may tell you if it is a metal or a non-metal, and may also describe the what group in which it belongs in the periodic table. Elements in group 1, 2, and 3 are metals most likely. Elements in group 4, some are few might be metals, some are mostly semi-metals. But elements in group 5, 6, 7 are non-metals. Elements in group 0 are the noble gases. So you can see 16, that is C. C that has an atomic number of 16. The first shell will occupy 2 electrons. Second shell will occupy 8 electrons. 2 plus 8 is 10, remaining 6. The last shell occupies 6 electrons. This element has 6 electrons in its atmos shell. It is not a metal, because metals usually have between 1 to 3 electrons in their atmos shell. So since it has more, it is not a non-metal. So this element is a non-metal, and it most likely belongs to group 6 of the periodic table. So maybe it might be sulfur. I think this is sulfur. D that has an atomic number of 20. Let us split it. 20. First shell 2 electrons. Second shell 8 electrons. That's 2 plus 8, 10. Third shell 8 electrons. That's 18. Last shell 2 electrons. So this element has 2 electrons in its atmos shell. It is definitely a metal. In short, this element is calcium, and it has 2 electrons in its atmos shell. It is a metal. So the correct answer should be element D. So A will be your correct answer. But if you look at your past question, you see that they choose D, which is a wrong answer. We've proven it that A is the correct answer, because D is the only element here that is a metal, and in short, is most likely is calcium, because calcium has an atomic number of 20. So your correct answer is what? A. Question number 27. CH3COOH is it tribasic? Is it monobasic? Is it dibasic? They are asking you basicity here. Ignore this uni ionized. That's not, they're not asking that. What they are mostly asking you here, if it is they are tribasic, monobasic, or dibasic. So the answer is between A, B, and D. We want to know the basicity of the acid. So look at what I said here. The basicity of an acid is the number of replaceable hydrogen ions in one molecule of the acid. The basicity of an acid is the number of replaceable hydrogen ions in one molecule of the acid. Now let us see the equation below. Now remember that an acid reacts with a hydroxide to form salt and water. As an acid reacts with a base to form salt and water. What happens is that the metal in that base usually displaces the hydrogen. So the metal will replace that place that the hydrogen is. Then the hydrogen will now join with the hydroxide of that base to form water. Do you understand? The metal now, sodium, will stay here where this hydrogen is. This hydrogen will now combine with this OH in the base to form H2O. Are you following? So the number of hydrogen that this metal, either sodium, calcium, or any metal, can replace in an acid is known as basicity. So if you see here, you see that this compound CH3COH is ethanoic acid. It actually has 4 atoms of hydrogen, 3 here plus 1 here, that is 4. But out of these 4 atoms of hydrogen, only 1 is replaceable by what? NaOH. Only 1 is replaceable by what? Sodium, rather Na, sodium hydroxide. Only 1 is replaceable by sodium hydroxide, Na, to give CH3COONA plus H2O. So we see from the equation above that blah blah blah, this has 4 atoms of hydrogen, but only 1 atom of hydrogen has been replaced by sodium atom. Therefore, CH3COH is monobasic. Since only this hydrogen is replaced, it is monobasic. Mono, 1, di. 2, di or bi. 2, tri, 3. So only 1 hydrogen is replaced, it is monobasic. So the answer here is B. So B is your best answer. Question number 28. Which of these salts will give a precipitate when treated with NaOH solution? Which of these salts will give a precipitate when treated with NaOH solution? Now, the first thing you should do is to open up and try checking what will be the product when each of these reacts with NaOH. The first one is ammonium chloride. When ammonium chloride reacts with a base, it gives ammonia gas. So NH4Cl plus NaOH will give you NaCl plus H2O plus ammonia gas. So even if ammonium chloride reacts with calcium hydroxide, it will give ammonia. Even if ammonium chloride reacts with potassium hydroxide, it will give ammonia. Take note of that. Whenever ammonium chloride or any ammonium salt reacts with a hydroxide, it must give what? Ammonia gas. So NH4Cl will react with NaOH to give what? Ammonia gas. Now the second one, AlCl3 plus NaOH, we give what? AlOH into bracket 3 plus 3 NaCl. So here, aluminum chloride will react with this base to give a white precipitate of what? Aluminum hydroxide. Here, CH3COO, sodium ethanoate, it will react with NaOH to give what? Na2CO3 and methane gas. So this one usually reacts with this base to give a methane gas. Then in this one, Na2CO3, of course, if you react this NaOH with washing soda, Na2CO, there's no visible reaction. So the only one that will give a white precipitate with NaOH solution is what? AlCl3. Only AlCl3 will give this white precipitate when treated with what? NaOH. So your best answer is what? AlCl3. Question number 29. The process whereby a salt loses its water of crystallization to the atmosphere is in exposure to air is? The process whereby a salt loses its water of crystallization to the atmosphere on exposure to air is called? The answer is efflorescence. Out of all these options they gave you, it's not effervescent, it's not the liquescent. The best choice is efflorescence. What is efflorescence? Efflorescence is the correct answer. Why? Efflorescence is the process whereby a salt loses its water of crystallization on exposure to air. That is what efflorescence is. Look at this equation below. You can see here, this washing soda, it contains 10 molecules of water of crystallization. It contains what? 10 molecules of water of crystallization. So when you expose it to air, it's going to lose 9 out of these 10. You can see here Na2CO3.H2O, sorry, plus 9 H2O. So it's going to lose 9 out of 10 molecules of this water of crystallization on exposure to air. So that's what efflorescence is. And as you can see, I gave you a typical example on efflorescence. Okay, so efflorescence is your answer. Question number 30 and the last for today. Which of the following elements can catenate? Which of the following elements can catenate? What is catenation? Catenation is the process by which carbon forms long chains and rings, as seen in very large hydrocarbon molecules like starch. So that's what catenation is. The process by which carbon form long chains and rings. You can see it in starch, you can see it in cellulose, you can see it in many other large water molecules. That process is known as what? Catenation. You can even see it in fats and many other carboxylic acids like glycerol and so on and so on. So that process whereby carbon form long chains and rings is known as catenation. So out of all these elements, the only one that can form that long chain and ring is what? Carbon. Students, we have come to the end of today's section on chemistry. So if you look below here, you are going to see a link. So you are going to use this link to join us on our WhatsApp group. If you do, you are going to be getting updates and infos on the latest videos we have on YouTube that you may find very interesting. So try as much as possible to join us on WhatsApp. Like our videos on YouTube. Try as much as possible to also share our videos, because there are many students that are looking for this opportunity. You may not know, so they may be your friends. So try as much as possible as you watch these videos, you like, you drop your comments and also share our videos. So till we meet again, my name remains Mr. Chima, and I'm your prep class tutor on chemistry. Bye and stay safe. Cheers.